Hello everyone, welcome to my presentation on my research topic of implementation of management systems for natural gas transportation logistics in Australia. Before going ahead with my presentation, I would like to introduce myself. My name is Daniel. I'm doing my first semester for Masters of Engineering Masters in Engineering Management from University of Wollongong. So this is also my one of a research topic in my core subjects. So going ahead with the presentation, as the terminologies represents here, we are trying to develop and propose the design for having a management systems for natural gas transportation logistics. The natural gas transportation would have several categories and several criteria involved in it, which would start from the pipelines, as they are the major entities, the compressing units and the stations and the receiver end and the distributor end and the loader end. All the parties which are involved can be managed simultaneously to have a better transportation logistics systems, which could easily mitigate the losses and reduce the amount of risk involved in the transportation procedures. Going ahead with our presentation, the overview of my presentation would be consisting of introductions, the framework which we have already proposed, which is already a proposed study, and the objectives related to the MSGTL, and the set of tools and methodologies, the transportation system availabilities, and ended with the conclusions. Rather not wasting time, going ahead, introduction of starting from what the transportation systems in the pipeline means, starting from the source to the consumer. All the entities involved in it would be a part of the logistics system, would be a part of the transportation system. So having a management systems to mitigate the losses, to reduce the amount of risk, to have a governing body over each and every objects and entities in that pipeline network is a major factor, and that is why we are doing the study on the same. The basic necessity would be to have an efficient and a robust distribution of the energy from the source to the client, which is the main entity, that is the main important cause and main important reason of why we are doing this study. An important characteristics of the gas supply is to dependency on the dedicated pipeline networks. Though it is very fragile, but the dependency of the gas pipelines of the gas transportation would be completely relying on the gas pipeline networks rather than any other transports, because of the dependability and continuous flow and the lower cost. All the energy supply systems operate at a certain intrinsic level, so each and every operating entity, which I had discussed earlier, has a certain intrinsic level of risk. Each and every risk involved has a certain outcomes. So what we are doing here, we should first involve and first we have to find out what is the outcome and the impact of the risk, and by using different simulation softwares and thermodynamic simulations. And these losses can be mitigated by, after evaluating them, their intensity, and considering and marking them in a criteria stating from the higher level of risk to the lower level, and having a methodology to rectify those risks and overcome those risks by having another alternative at the same time. System reliability can be improved by constructing alternatives for the disruptions. Any disruptions in the pipeline networks could be a maintenance failure or an instrumentation failure in the pipeline network. It can be rectified by having a standby unit at the station, or having a standby supply unit, or having another alternative source of transportation, a standby pipeline. These all decisions can be made at the pre-construction stage, as well as in the operational phase. We can determine when these errors can occur using the help of a Monte Carlo simulation, which use random iterations to find best possible outcome. Coming to the MSGTL framework, the MSGTL framework consists basically of two types, and each and every part has their own importance. One would be basically important for the construction phase, and one would be on the pre-construction and operational phase. The Monte Carlo simulations is to determine the availability of compression stations and economic risk analysis. As I have discussed in the previous slide, these simulations use the random iteration particles and compute it to find a better solution and to find a perfect solution. Though it is a suboptimal level solution, but these solutions can be further rectified, can be further combined with the help of a thermodynamic simulation and other simulation factors, and computing it together to find a final outcome in the pre-construction as well as post-construction phase. Operational gas pipeline uses information about compressed unit failures and which are detected by the SCADA. As I was telling, this system would be using most of the technology factors, simulations. So the SCADA is one of the best user interface feedback system. Any errors in the pipeline network will be notified to the operator of the SCADA within seconds of time. They would exact know the location and the point of place where there would be a leak or there would be a mishap. These SCADA informations are critical for any further planning, for any further forecasting, for any other new expansion of the projects. These SCADA informations are much reliable. So the third outcome in the MSGL framework would be the contractual constraints between the loader and the distributor and the loader and the transporter. So the loader and the distributor and the loader and the transporter, these basically are two different entities. So these two entities will be having different contractual constraints and contractual penalties and clauses. Going to the next slide. Here, as I have mentioned in the previous slide about the framework, this section would be considered as a section where we will be using the MSGTL system for the pre-construction phase, and the white section you can see as it can be used for the operational phase, where Monte Carlo simulation is the initial start base, combining with it the thermodynamic simulations, using the frequency and the capacities which have been resulted out by the Monte Carlo simulation and the thermodynamic simulations, and the economic evaluator can be sitting on those frequency and capabilities, estimating the taxes and tax capacity allocation, and the tax decisions can be made at the end, and providing a final pre-construction plan with the help of the MSGTL system. In the operational phase, we can determine the linear programming, which it takes random iterations, which uses random variables and provides exact amount of numbers of quantity used to be quantity described quantity for gas accumulated and quality of collected at the receiving end, at the distributor side and from the transporter side. And here we have another thermodynamic simulation in the operating phase and the normal final reports, which would be used further for the pre-construction and any future forecasting demand. The objective of the MSGTL system is to maximize the selling of availability of gas and fulfilling the distributor demands. To maximize the selling of the available gas supply and to fulfill the incorporated process and the related natural businesses. Use the statistical distribution curve as a process to evaluate and project obtaining the variables and the volatile behavior. These statistical distribution have been provided with the help of the simulations, as I have said in the previous, which contains in the MSGTL framework. This is a flowchart diagram which would be mentioning about from the gas producers, all the entities which are involved, as I have said in the beginning. The gas producer, the loader, the distributor, the thermal plants which are a consumer in this section, and we have a gas transporter over here. So these will be having different contractual terms, and these will be having different contractual terms this will actually help to mitigate the losses and mitigate the losses and reduce the amount of risk involved by both the parties. Set of tools will be used. Here we have a linear programming consideration. Here we will be having a transport network and illustration of delivery points and the receiver points. The methodology, it's already been implemented in one of our gas board project and with Brazilian Bolivian government projects. So the results were pretty convincing, and that's why we can implement it in Australia as well. The conclusion of this would be the management of natural gas business due to the complexity of the network and contractual relationship among the agents, because we have a wide variety of resources and basins and pipelines. It is essential to have a management systems which could mitigate the losses and which could reduce the intensity of risk involved by contractual parties.
Yes, sure.